All right, hello, this is 12.7 theoretical and experimental probability. And we're going to go ahead and start with definitions. So an outcome is the result of a single trial, such as spinning a wheel. The space sample, or the sample space, is all the possible outcomes. An event is an outcome or group of outcomes. The outcome that matches a given event are favorable outcomes. And the probability of an event tells you how likely it is to occur. Alright, so we have, starting off with theoretical probability. So in order to find theoretical probability, we find the number of favorable outcomes and the number of possible outcomes. Here I have an example for you. So example, rolling an even number on a dice. So first let's think of all the total possible outcomes that we have, which would be our denominator. So we could roll a 1, 2, 3, 4, 5, and 6. So we have 6 possible outcomes, and then number of favorable outcomes. Well, how many even numbers are there on a dice? So we have 2, 4, and 6, which means 3. And you never want to leave your answer like this if you could simplify it. So that could be 1/2. Alright, our next example, it says our solar system, it's 8 planets in order from least to greatest from the Sun, are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. You will randomly draw from one name of the planets and write a report on this planet. What is the theoretical probability that you will select a planet whose distance from the Sun is less than the Earth's? So remember, our probability of event is equal to possible outcomes over favorable. Alright, so how many planets do we have there? If we count all of them, we would have a total of 8 planets. Then, how many of those planets are closer than the Earth? So if you look at the solar system, Mercury and Venus are closer to the Sun than Earth. So that's 2. And again, you want to simplify this, so this would be 1/4. And that would be our answer. Alright, so next we're going to talk about the complement of an event consists of all outcomes in the sample that are not in the event. So we have 2 formulas here. So we have probability of not the event equals 1 minus probability of the event. Probability of event plus probability of not event equals 1. So the possible outcomes for rolling a number cube are 1, 2, 3, 4, 5, and 6. And if we want to say probability of not rolling 6 plus probability of rolling a 6, that should equal 1. So let's go ahead and do that. Probability of not rolling a 6, that would be 5 out of 6, plus probability of rolling a 6 would be 1 out of 6. So yep, that's true. Alright, example number 2. In a taste test, 50 participants are randomly given a beverage to sample. There are 20 samples of drink A, 10 samples of drink B, 10 samples of drink C, and 10 samples of drink D. What is the probability of a participant not getting drink A? Alright, so probability of not getting drink A that's going to be 1 minus the probability of getting drink A. Okay, so what's the probability of getting drink A? So total we have 20 plus 10 plus 10 plus 10. So in total we have 10, 20, 30, 40, 50. 50 total drinks. And for drink A, we have 20. So those are the favorable outcomes. We have 20 samples. So then you could go ahead and do common denominators. So I'm going to go ahead and use a different color here. And then I'm going to go ahead and subtract 50 minus 20, 30 over 50. So we get 3/5. So the probability of not getting drink A is 3/5. Alright, odds describes the likelihood of an event as a ratio comparing the number of favorable and unfavorable outcomes. Odds in favor are number of favorable outcomes over unfavorable, and then odds against are number of unfavorable over number of favorable. Okay, so what are the odds in favor of landing on a number greater than 6? And I'm actually missing a picture here. So there's a spinner, and we have 1, 2, 3, 4, 5, 8, and then it has a little spinny arrow that would spin around. So we're going to go ahead and look at odds in favor. So we're going to look at favorable outcomes. So greater than or equal to 6 would be 1, 2, 3. That would be 3. And then unfavorable outcomes would be the rest of them. So 1, 2, 3, 4, 5. So that would be 5. So my answer there would be 3/5. Okay, next we're going to go over experimental probability. So this is where, let's say you would actually perform an experiment, and so the number of times the event occurs and the number of times the experiment is done, that's the probability. So it says, after receiving complaints, a skateboard manufacturer inspects 1,000 skateboards at random. The company finds no defects in 992 skateboards. What is the probability that a skateboard selected at random has no defects? What is the probability as a percentage? Alright, so we're going to go ahead and find the probability of no defects. And so we want the number of skateboards with no defects over the total that was taken in this inspection. So in total we had 1,000 that were inspected, and we had 992 with no defects. So we're going to go ahead and plug that into the calculator, and we're going to get 0.992. Okay, then if we convert that into a percentage, you could move over the decimal place twice. So 1, 2, and so it would be 99.2, and you move that over to the right. Or you could multiply by 100. Okay, or you could do 0.992 times 100, and that would also give you 99.2. Alright, so question B says, if 10,000 skateboards are manufactured, how many won't have defects? So what you want to do here is you want to multiply that number times 10,000. And then go ahead and plug that into your calculator. So in total, if you produce 10,000 skateboards, you should have 9,920 with no defects. So this is a really good way to, if you're in the manufacturing business, to take a sample of things and then kind of estimate what your defects is for your entire products. Alright, and this is going to be your homework, so go ahead and write that down. If you have any questions, please go ahead and email me or contact me.